Hello students. Today we will discuss about routing in network layer. So what are the concepts related with routing, delivery, forwarding, etc. and some important protocols, how to find a route and many more things. So if we remember, we know that delivery is a process done by the network layer to send and receive, or in short you can say delivering of a packet to the upper layer, right? So delivery of a packet is a first task performed by network layer. So now delivery methods can be of two types: direct delivery, indirect delivery. Now you can see in the diagram, direct delivery is a process when network is same and packets can be delivered from one client to another client directly. But if networks are separate, then again obviously there will be some connection mechanism or connecting device should be there, which is router and which is responsible for delivering the packet. So now one more very important term is here, it is known as forwarding. Forwarding means place the packet in its route to its destination. Mind it, proper route selection is also very important. We have discussed like router has number of input lines and number of output lines, and with the help of routing protocols, shortest path, etc., we will see in later lectures, through which router decides on which particular output line packet will be placed so that it can reach its destination properly and with short span of time, right? So forwarding requires a host or a router to have a routing table. So how we can, suppose if we want to go somewhere, or maybe sometime we visit to some other city or some other country, then people will use tour guide kind of thing, or maybe some printed booklets are available on different spots, tourist places, so that you can find out the important places, destination, how to reach medium, etc. Although nowadays these things are very much covered by the Google Maps, etc., but if we see the traditional method, we have some document kind of thing which is known as your guide booklet, which can give you the route. So similarly, routers maintain a routing table, means how many different routers are available and how many different routers are connected with each other. They share their connectivity information with all details, very much similar to graph, where one node is connected with another and some cost is defined between these two nodes, and cost is something which is defined on the depending upon the type of network, right? So routing table will be the main thing on which router works. So what different type of routing tables are there? Different type of approaches are available to define this routing table. So suppose there is a network, you can see in the diagram R1 and R2 are the routers and two different hosts are on two different networks. So suppose if you see routing table for host A, routing table for R1 and routing table for R2, which is written in between the two. Then routing table based on route is defined on the first part, left hand side, and routing table based on next hop. Hop means next particular router, which is known as hop. So if we see the first table, then routing table of A suggests that if destination is host B, then route will be R1, R2 and host B, obviously, which is very much clear to see the diagram. When we see the diagram, then in case of R1, we can see if host is B, then R2, then host B, and similarly things are defined. So this complete route is available in routing table. Then if we use the next hop, means next connecting device or router name should be there. So host B, next hop is R1, host B, next hop is R2, and then host B, then no next hop is required. So we can see the different position of routers and routing tables. This can be a method. Then one more method is there, host specific versus network specific. If you see N1 and N2 other networks, N1 has only one host and N2 has four different hosts are there, and R1 is the main connecting router between these two networks. So if we see the routing table on host S, you can see destination and next hop. And if we see routing table based on network specific method, then N2 will be the network and next hop will be R1. So routing table will size will be reduced. Now default method is destination N2, next hop is R1, any other R2, means rest of the internet and some other networks are related with in this manner. So these are the different type of routing tables which we can use. Now in classless addressing, we need at least 4 columns in routing table. I think we have learned classless addressing in previous lectures. So unicast routing protocol. A routing table can be either static or dynamic. Obviously, we can fix manual entries can be done in routing table, and automatically we can update or generate routing table. And obviously automatic table and routing methods are very important, and nowadays everything is automated and a number of protocols are available to perform this operation. And why is this updation and everything is required, which we'll see in later slides. So optimization, inter routing, and few important routing algorithms and their protocols are mentioned here. So now you can see autonomous system. How we can define this autonomous system means separate network entities are known as autonomous system. Every network has their own setup and they are connected with some connecting routers. So these are known as autonomous systems. Then routing protocols are defined in intradomain and interdomain. Interdomain routing protocol uses two different algorithms, distance vector algorithm and link state algorithm. And on the basis of distance vector mechanism, routing information protocol RIP is developed, and for link state routing, OSPF, open shortest path first protocol is there. And for interdomain, which is also known as path vector method, and the protocol is known as BGP, border gateway protocol. And here I will strongly mention this thing. BGP is known as glue of internet. Glue means a thing which stick different networks with each other. So in case of internet, to connectivity with different networks, BGP is responsible and used. And for other network internal transmission, everything, intradomain will be used, and there are two different methods mentioned here and their protocols are there, right? So now first come with the distance vector routing algorithm. Let's take an example. You can see the graph, and all the nodes are considered as a router, and I have mentioned the cost only one because we can simplify the calculation and learn things fast. So in this case, in distance vector routing, each node constructs a one-dimensional array containing the distances to all other nodes and distributes that vector to, vector means that distance, to its immediate neighbors, right? If suppose one router doesn't know the, and there's no direct path between these two, then unknown or infinity will be marked in the routing table. Suppose A is not directly connected with D, so when A will prepare a routing table, D will be marked as infinity or question mark, means there is no entity or cost known by the A. When router will exchange their routing tables, then they will update accordingly, right? Now if we see the global table of this particular network, you can see stored at node A. Suppose on node A, what will be the scene of table? A to A distance will be 0 because obviously self distance will be 0. A to B cost is 1, we can see in the diagram. C because directly connected. D is not directly connected, so question mark or infinity sign will be there. And E1, F1 and G is again unknown because distance vector is working on directly connected neighbors. So this will be the scene of global routing table, and each and every router will maintain his or her own table separately as well. Apart from this global view, this can be the table for server or maybe main network router. So how these question mark will be replaced? Because whenever data packet comes to router A and after processing destination address, it will be declared that this packet will be delivered or sent to router D. Then how A will know that he can send the packet through B, through C, or whatever will be the path, or maybe D is there in the network. So this particular thing will be done by when initial table will be created by all the routers with the connectivity to its direct neighbors. The routing table will be exchanged and shared with each other. Every router will send its routing table to its immediate neighbor. So this will be defined here, what I have explained. So now if we see after exchanging of the information, now you can see the global routing table will be updated as now A knows cost to B reached B is 1, C is 1, D is 2, because now A knows the cost to reach D is 2, but this is half of the information. That next will be in the next slide. So all these question mark entries are now updated because every router share its information to its neighbor. Suppose D shared information with B, then B shared with A, then A know how to reach the D. Now you can see the forwarding table consists of 3 entries: destination, cost, and next hop. Now you can see a particular routers table. Suppose I have taken an example of node B's routing table. Then B will enter what? Destination, cost, and next hop. Then destination if A, cost will be 1 and next hop will be A. Similarly, and so now see, if B wants to reach D, then cost will be 2 and next hop will be C. So via C, B knows that now B knows that that particular router will be reached, which is known as D, by the cost 2. So B can reach to D via C, cost is 2. And similarly, all the routers maintain this individual table for their own references. When packet comes, then they will find out the network address and find out the next router. Then they watch and then they process their routing table, how the route will be or path will be defined to reach that particular, or next hop will be, which router will be the next hop, so packet can hand over to that router and so on. So in this way the complete routing table will be maintained, right? And on an average or a standard, when RIP protocol is developed on based on distance vector algorithm, on every 30 seconds a router exchanges their information with each other so that they can update it. Maybe some topological change, maybe A is directly connected to B, now A is connected to C and D only, connection between A and B will be removed, or maybe some link will be permanently down. Then how routers will know these things? Because they have to exchange and share their routing tables between each other on some interval, right? And the most important thing which you have to learn, distance vector routing follows Bellman-Ford algorithm to update these routing tables. I hope all of you have remembered the Bellman-Ford algorithm which you have studied in the paper of DA, Design Analysis of Algorithm paper. Bellman-Ford algorithm is used to initialize the routing table, and after the exchange they can update their routing table on the basis of logic of Bellman-Ford algorithm. Okay, so this is the method, or this is the thing which is very well used in distance vector routing. Now further we will discuss their drawbacks and etc. Now come to the next routing algorithm, which is link state routing. Link state routing is just opposite to distance vector routing. Link state routing says, suppose if we differentiate these two on the basis of one major point, although working and methodology and protocols are also different, but the basic difference, conceptual difference, is distance vector routing algorithms shares entire network information to its neighbors only, direct connected neighbors only. Entire network's knowledge to their directly connected neighbors. And link state routing is sharing. In link state routing, the router shares their neighbors' informations to internet. Although when we listen this particular thing, we find it similar, but there is a very small difference, but it makes a huge difference between these two. Link stays in link state, router informs their neighbors detail to whole network, and distance vector, whole network information shared with the directly connected networks. So in this way, these two algorithms are different, and in for this purpose, obviously, if we want to share our neighbors information to all the routers, then obviously one packet is created, and the concept is known as reliable flooding. Means every router did the same, so suddenly more packets are there on the channel or on the links. So it's a kind of flooding state. So link state packet LSP is generated by the routers, which consist of ID, which created the LSP, directly connected neighbors of that node, and cost will be the data in that packet, and a sequence number, which is also very important. Why we share a sequence number? So these three entities will be shared in the one LSP packet. So suppose there is an example, if X receives a packet from Y, then it checks the sequence number. If sequence number is new apart from the previous one, then that particular sequence number packet will be treated as more updated, and the routers will update their routing table on the basis of this information. And mind it, link state routing uses Dijkstra algorithm. Again, Dijkstra is very much known algorithm, and all of you have studied in data structures and DA both, to update their routing table informations when they exchange their tables. As you can see, I have mentioned this thing in this algorithm. So these two algorithms are well-known algorithms for the routing, and after this, shortest path will be found, and then packets will be sent to their destination. So this is all from today's lecture. Thank you.